Hello, this is Unsweetened Uranium here. Welcome to the first video on the channel. Today we're going to be talking about alkanes. So I want to start this channel with a video about alkanes because, well, the first subject we're going to be covering is organic chemistry. One, we might get up to organic chemistry two, we'll see. But for organic chemistry one, you're going to hear this word a lot, an alkane, right? Your professor's going to use it all the time. You're going to see it on exams. You're going to see it on homework. So this is a little intro into just exactly what they are. So let's get started. We're going to draw a Lewis structure for a molecule you might have seen it in Gen Chem 1. You've definitely heard of it because it's called butane and it's used in lighters and also sometimes used as a propellant, like aerosol sprays, stuff like that. Um, Not N-butane, but isobutane, I believe, is also used to raise the octane of gasoline. So it has some uses. I'm just going to draw the Lewis structure here. Give me a second. So I want you to observe this while I draw it and write down two observations. Write down two observations, just first ones that you see. Remember, there's no wrong answers in chemistry, but there are silly answers. So be careful what you write. Okay, here we go. Butane, beautiful. Look at that. All right, so hopefully you wrote down two observations. Let's see if any of them matched. So let's count our carbons. One, two, three, four. So I'm just going to label those first because that's going to help us in a bit. So we have one, two, we have three, and we have four. Now, I want you to look at these carbons. Single bond, single bond, single bond. Interesting. Do you know what the name of a single bond is in the chemistry world? Well, if you didn't hear it in Gen Chem 1, it's called a sigma bond. So we have a sigma bond here, we have a sigma bond here, and we have a sigma bond here. So you should be picking up on a trend. It's called an alkane. All the carbon-carbon bonds, right, between these two carbon atoms are single or sigma bonds. So you should notice that. And then let's look at what our compound is called. ANE, butane, alkanes. Interesting. So this but right here, right? This butane, or this but, and then the ane is saying that there's four carbons. One, two, three, four. The but part. The ane tells us that they're all single bonds between the carbon atoms. Okay? And if you notice, for alkanes, there's a neat little formula I want to show you. C N H 2N N plus 2. Now you might have seen this formula before. So it's essentially telling us that for alkanes, our C subscript N, which can be a number of carbons, so 1, 2, 3, 4 in this case, it's pretty much telling us that if we know our number of carbons in an alkane, this just applies to alkanes, right? And not cycloalkane. We'll get to that. But just for linear alkanes or N-alkanes, we're going to have CnH2n plus 2. Let's try this out. So we have C4. Okay, we know that. We counted them. H are hydrogens. Let's see what we have for hydrogen. So we have 2n plus 2. So if I do my math right, 2 times 4 is 8 plus 2 is 10. So using that little trick, I didn't even count these yet. Let's count them now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nice. And let's undo those because those look like radicals, and we'll get to radicals. But all right. So formula checks out, right? So that's the second real thing I wanted to address, right? So the first thing was carbon-carbon bonds are single bonds, sigma bonds, and then we have this formula we can use to determine, right? It's a linear alkane. All right. just an alkane in general. This will work for most alkanes, except cyclo, right? Because then we're going to have, that's going to get complex. But bear with me, one step at a time. So I just want to address another interesting thing, right? So the order generally goes, right, for most things. Gas. In this order, it could go either way, right? Especially when we think about ice, right? A lot of people think about like solid to liquid to a gas. I don't have my mouse on me right now, so apologies. All right, gas, liquid, solid. We got all three, right? And the plasma fanboys will hate on me, but for the sake of this argument, we have the three we need. So, methane. You've heard methane before, right? Is methane a gas, a liquid, or a solid? Methane is a gas, okay? Methane is a gas. Butane is a gas, right? But once we start getting higher and higher, especially around like 9, especially when we get up to 17, right? They start becoming liquids and solids, right? They start becoming liquids and solids. The larger that carbon backbone is, right? So you want to think about it as a backbone, right? Think about this as the carbon backbone. The more carbons we add, right? It's less likely to be a gas, can be more likely to be a liquid, and we keep making it even larger. It's going to become a solid, right? So that's just something to think about. They're not always going to be a gas, they're not always going to be a liquid, and they're not always going to be a solid. It really depends on the carbon backbone, okay? So, next thing I want to address was that all alkanes are colorless, right? So if you get a question on exam, can you, whatever, can you see the alkane? Like, does the alkane appear orange? Just a straight hydrocarbon, so just hydrogen carbon alkane, right? No other, nothing else attached. We're just talking pure alkanes. Will always be colorless. Okay, so we'll get into color in another video, but this will be colorless. Okay, so another thing I want to talk about was the last part of this video, but it's about reactivity. So you're going to get into a bunch of reactions with alkanes, and yes, you can do reactions, right? You can do radical substitution, all that fun stuff. But generally, they're considered unreactive, which sounds strange because you know, like, oh, I know about alkanes. I've heard of octane, which you should know is 8 carbons, and you know, you put it right. It's one of the components you put in your car. So people are like thinking, oh, it's not reactive, but we use it to power our engines, right? You have a car. Okay, you get in your car, you start the engine. Boop. Pretend that's a little spoiler back there, right? You get in your car and you start up, the engine starts running, right? And as the engine starts running, right, you have CO2 and water coming out the exhaust, and you're thinking to yourself, okay, now I'm using this energy to move my car, right, forward through the transmission, all that fun stuff. That's more physics. But you know you put gas in your car and it reacts and it's reactive enough, right, to move a car. So you're gonna say, hey, unsweetened uranium, what are you talking about? That this car is alkanes aren't reactive, right? You're saying they're unreactive. I use it to power my car. Explosions within my engine. Well, yes, when you give them enough energy, and you'll learn about activation energy, when you give them enough energy, they form really stable products, CO2 and water, some of the most stable products we know of, right? But this right here, this is a high activation energy. So you want to think about it as if you had a barrel of gasoline in your garage, right? It's just sitting there, right? And it's just sitting there, and it's open, so you'll have some, right, evaporating, especially if it's a lighter one. We talked about gas, it'll be going between, depending on the temperature, it could be, right, evaporating a little bit till the vapor pressure comes down. Anyways, that's too complicated. But pretend we just have a barrel sitting there of gasoline, right? And it's just sitting, right? And let's just pretend it's mostly alkanes, right? So pretend it's sitting there and nothing will happen. Okay? We don't have enough energy in the room to get over here, right? We don't have enough energy. So I'll put this graph as energy. I should have done this before, but energy increasing, right? So the gasoline is just sitting there and nothing happens, right? It's safe to leave. You can leave like a can, right, for your lawnmower. You can leave in your garage and stuff, right? Stuff like that. Nothing's gonna happen. What would happen if I put a spark plug in there, right? So anyone who knows a little bit about cars will know spark plug, right? What ignites the fuel when it's in the cylinders. But for anyone who doesn't know, basically a spark plug just gives a little bit of electricity, right, to ignite the fuel that was injected into the cylinders. So we have our little pretend. I'll just do a little lightning bolt. Nice. So we have electricity. It's the spark plug. If I put that in this, it ignites. We gave it enough energy, right, to get over the activation barrier, and CO2 and water were formed down here, right? And the oxygen, right? Because if you look at pretend, I know butane is a gas, so let's just pretend octane. So add four more. Pretend it's a liquid down here, and we put the spark plug in, right? So we have our octane. We ignite it. We give it the energy it needs, and then it comes down here. So down here we're gonna have CO2 and water, but you're gonna be looking. I see hydrogen, carbons, no oxygen. How am I making CO2 without oxygen? Well, you do have oxygen from the atmosphere. So if you did this, right, with no oxygen, what do you think would happen? I want you to leave that in the comments. What do you think would happen if I try to ignite this barrel, right? A combustion reaction, and pretend there's no compounds with oxygen here. So just carbon and hydrogen and electricity. And there's no oxygen anywhere, okay? I want you to type in the comments what you think would happen. All right? And that's all for this video. This is just a brief introduction to alkanes. So, a little review for the video ends. So, alkanes, what you should take away from this lesson, the three main points is that you have this carbon chain, right? They're all single bond for an alkane. That's the qualification. Look, single bond, sigma bond, right? Another sigma bond, right? These carbons are all connected by one bond. That's what gives it its name, alkane. Okay, we use butane, for example, right? We could have done methane, ethane, propane, butane. You've heard of all those, right? So this ane ending gives it away. So if you saw butane on a test and the teacher goes, give me the skeletal formula, right? 1, 2, 3, 4 carbons. We don't have to draw hydrogens because they're implicit. You would draw this. Or you could draw this, especially if you're new to organic. The professor might not expect you to do this yet. He will definitely by the end of the semester. But if it's a first exam, a first quiz or something, he most likely will still allow Lewis structure. But if you guys want a video on skeletal structure, it's not too complex, but I can make a video on it if you guys would like. And then this formula, good to know, a little good thing to have in your pocket for an exam. You might want to know. So we have 1, remember this, 2, remember this, and 3 is the nomenclature is important, okay? You got to learn the nomenclature. Just look at some examples online, get the nomenclature down. This is more fun fact stuff over here, right? You don't necessarily need to memorize it, but if you want to know something from this, just know that they're generally unreactive. We consider them unreactive because of this large activation energy. All right, that's all I got for today. Have a good one.